All right, so chapter 1, lesson 4 is ratio tables. Okay, so for the warm-up, it says a punch recipe uses 1 container of soda and 3 containers of juice to make 1 batch of punch. Number 1 says draw red counters to show the number of counters of soda and draw yellow counters to show the number of counters of juice needed to make 2 batches. Okay, so the first thing we need to know is that, let's see, the punch recipe uses 1 container of soda and 3 containers of juice to make 1 batch. So what do I need to do to make 2 batches with that information? Multiply by 2. Very good. And if you don't have colors, you can just do it like this. Okay, red and yellow. So I have 2 red, 2 containers of soda, and yellows for the containers of juice. Now, where's my? So, what is the ratio to make 1 batch? The ratio is for sodas to juice, it's 1 to 3. Very good. So the ratio for the second for making 2 batches would be 2 to 6. Very good. 2 to 6. All right. Number 2 here says draw red counters to show the number of containers of soda and draw yellow counters to show the number of containers of juice to make, now this time, 3 batches. So what am I going to do to that first ratio? We're going to multiply by 3. Very good. So we're going to have 3 containers of soda and 9 containers of juice. So what's my ratio going to be for 3 batches? 3 to 9. Is everybody with me? Now, what do we notice? Okay, so the first ratio was 1 to 3. The second ratio was 2 to 6. And the third ratio was 3 to 9. Right? What do you notice with those ratios? Yes, yes they do. But what else more important do you notice there? Yes. Good. When you simplify them, they all equal 1/3, right? If we divide this by 2 and divide this by 2, that equals 1/3. Divide this by 3 and this by 3, we end up with 1/3. Is everybody clear? So now we're going to talk about equivalent ratios. Now I want you to make sure that we write down the definition for the ratio table. Now it says the quantities in the opening activity can be organized into a table. This table is called a ratio table. The reason that's called a ratio table, of course, is because the columns are filled with pairs of numbers that have the same ratio. And of course, if the ratios are the same, they are, of course, called equivalent ratios. So an equivalent ratio, make sure you write down this definition also, they express the same relationship between the quantities. Like in the warm-up, 1/3, 2/6, and 3/9, they all simplify to 1/3. So they are all equal. All right, so for the example 1, it says to make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. How much food coloring should you mix with 5 cups of white icing to get the same shade? So here we're looking at 6 drops of yellow with 1 cup of white icing. Okay, and then we want to change that to using 5 cups of white icing. So the ratio that we're looking in the table is going to be drops of yellow to cups of icing, right? So here's where I get 6 to 1. Now we want to end up with 5 cups of icing. Does everybody see that? You want to end up with 5 cups. So in order for us to get from 1 to 5, we're just going to multiply by 5. Now if I multiply down in the denominator, that's the bottom number down here, right? Then I'm going to have to multiply in the top. Does everybody see that? So 6 times 5 is 30. So that means I'm going to need 30 drops of yellow food icing to make 5 cups of icing. Is everybody clear? All right, very good. Now here, in the recent year, Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. He ate at a constant rate. Determine how many hot dogs he ate every 2 minutes. So, we're starting with the ratio 66 hot dogs in 12 minutes. So it's hot dogs to minutes. Is everybody clear with that? So hot dogs on top, minutes on the bottom. And you see how the table is organized? Looks just like your fractions, right? So here we've got 66 to 12, and then we want to know how many in 2 minutes. So here we're just simplifying. So we can simplify the 66, we can divide by 2 in the numerator and denominator. We end up with 33 to 6. Okay? Then you can simplify 33 to 6 by dividing by 3 again, and we end up with 11 to 2. Could I just divide 66 and 12 by 6 immediately? I'm dividing here by 2 and 3, right? So that means that I could divide both of them by 6, right? Because 66 divided by 6 is 11, and 12 divided by 6 is 2, right? But what they're doing here is they're just showing you that you can make several you can make more than one step to get there. Is everybody clear? So if you don't remember that you can divide by 6, you can say, oh, they're both even, we can divide by 2. But then you'll have to notice that you can divide again. Is everybody clear? All right, very good. All right, let's do these got it problems together. So example A, or got it A, says a patient receives 1 liter of IV fluids every 8 hours. So that's going to be liters of fluid to hours. So that's fluids to hours, right? And it's 1 to 8. So we're starting with 1 to 8. At what rate will at that rate, find how many hours it will take to receive 4 liters of IV fluid. So we want to go from 1 liter to 4 liters. Does everybody see that? So how am I going to go from 1 to 4? We're going to multiply by 4. So we're going to multiply by 4 up here, and we're going to multiply also by 4 down here. So 8 times 4 is 32. Very good. So writing our sentence, it will take, let's see. It will take 32 hours to receive 8 liters of IV fluids. All right, next one says, to make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberries. So we want to find the amount of sugar needed for 4 cups of cranberries. So here we are comparing cups of sugar to cups of cranberries. Okay, so it's sugar to cranberries. So that's 12 to 16. And it says find the amount of sugar needed to get to 4 cranberries. So the 4 is going to end up, we're going to put it at the end for cranberries. You got that? So let's do this in 2 steps, because you know that you can get to 4 by dividing by 4, right? 16 divided by 4 is 4, right? So we're just going to do a couple steps here. So let's divide by 2 first. Okay, I divide by 2 there, and then up here I can divide by 2 there. Then I will end up with 6 to 8. And then you can see again, oh, I can simplify some more, right? So you can see that you can divide by 2 here again, and you can divide up here again by 2. And then you will end up with 3 to 4. So that tells me that it takes 3 cups of sugar to make 4 cups of cranberries. All right, so now, once again, I want you to write the title here. We're going to use scaling. Now, scaling is multiplying or dividing 2 related quantities by the same number. That's what scaling is, okay? So when we are scaling back, of course, that means you're going to get smaller, okay? So am I going to multiply or divide to get smaller? You're going to divide. So for scaling back, we're going to use division, okay? For scaling back, we're going to use division. And then when we scale forward, we're going to use multiplication. Is everybody clear with that? All right. All right, for example 3, it says cans of corn are on sale at 10 cans for $4. We want to find the cost of 15 cans. Okay, so if I look at the table, and here they just, here, let's look at this table down here, because they're just filling it in over here. It says, okay, we want to go from 10 to 15, right? Now, you can see that you cannot go from 10 to 15 directly. Is everybody with me? So that's when we have to either scale forward or scale back so that we can get to the 15. So here we're going to scale back. So we're going to scale back first. So 10 and 4 we're going to divide by 2, and we end up with 5 to 2. So that's 5 cans of corn for $2. Okay, now you can see I can go from 5 to 15. Does everybody see how we did that? So 5 times 3, now we're scaling forward. 5 times 3 is 15, and 2 times 3 is 6. So that means that it'll cost $6 for 15 cans. All right, example 4. Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. At this rate, how many lawns would he mow in 49 hours? So down here, you can see we can't get from 14 to 49 directly, right? So we're going to have to scale back. So if I scale back, dividing by 2, because those, I can take that, divide by 2 because they're both even, I end up with 7 to 4. And now from 7 we can get to 49 by multiplying times 7. You see that? So 7 times 7, 49, and 4 times 7, 28. All right, so for the got it number C, letter C, it says a child's height measures in 105 centimeters. Estimate her height in inches. Okay? So let's see. So if a child is 25 centimeters in inches, they're going to estimate that child to be 10 inches. Is everybody clear? So here we want to get from 25 to 105. Can I get from 25 to 105? No. And I think I put an extra box in there that we don't need. Okay, so how about if I scaled back by dividing by 5? Okay, let's divide by 5. So, and does everybody see how I'm showing my work on the table? On your homework, you're going to write the table, and this is how you're going to show your work, okay? So we're going to divide by 5, and we'll end up with, see, 25 divided by 5 is 5, and 10 divided by 5 is 2. Now, can I get from 5 to 105?
Yeah.
Yes. So I put an extra table in here, an extra box in here that we don't need. Sorry, I'm just going to color that in so you don't get confused, okay? So we don't need that. So what are we going to multiply 5 times to get 105? Yes, we're going to multiply times 21. Very good. So if I multiply down here times 21, how many inches is that? Very good. So a child that is 105 centimeters, we can estimate her being 42 inches. All right, so for the last example, it says, on her vacation, Leah exchanged $50 American money and received $60 Canadian money. Use a ratio table to find how many Canadian dollars she would receive for $20 American. So here is the ratio table that we're setting up, and you can see that we cannot go directly from 50 to 20, right? So we're going to scale back. Both of those end in 0, so we know that we can divide by 10, right? So when we divide by 10, 60 divided by 10 is 60 divided by 10 is 6, and 50 divided by 10 is 5. Very good. So now you can see we can get from 5 to 20. You with me? So 5 to 20, we're multiplying times 4. So 6 times 4 is 24. So that tells us that Leah would receive $24 Canadian money for her $20 American money.